हाँ V naught होता है. Guys, it took me like 6 months to write this paper. I'm serious. So, if you want to show it, right, this is how you'll show it, is 2 ways to show this graph, okay? And one way, you remember, one is the phase, the other is the amplitude, yes? So 2 ways to show this graph would be, what is this? The first one is, that's the Bode plot, right? What is here?
Z.
What is here?
Frequency.
Frequency?
Yeah, frequency.
Frequency. Okay. And what is the other one? Nyquist plot, right? And okay, I've shown over here the Nyquist plot looks something like this. Okay. And let's call the point from here that goes to the top of the Nyquist plot as Z. Okay, that is the magnitude change. Okay, so you can maybe do, I'm not going to go into trigonometry right now, but like you can do this kind of thing. We will go into knowing how we use the Nyquist plot is more important. Okay, what about the Bode plot, guys? You know, what is it important for? What can you know from the Bode plot?
That's exactly what we don't know.
That's exactly what you guys don't know. Okay. Right, we will go through this later. Let's go through it step by step because I will tell you what the Bode plot can really be used for to see and how frequency is so important. Okay, what is the difference between DC and AC?
Average.
No, what is the difference between DC and AC? When you apply any of these techniques, they follow V is equal to IR, right? That's Ohm's law, right? So not this, here you have frequency, okay? There is no frequency there, right? That is the main difference. And what happens is, let's say the current can flow through 2 paths, okay? And let's say on top is a capacitor and on the bottom is a resistor, right? They're 2 different things, okay? A capacitor, what is a capacitor?
Something that stores charge.
Something that stores charge, right? Very simple.
To store.
It's important, guys, please just say, okay? Okay, what is a capacitor? You don't need to be shy, guys. Battery, it's like a battery, it stores charge between the 2 plates, right? There are 2 metal plates and the charge, oh man, I'm so
Not
bad.
actually connected.
We shall see.
Actually connected.
What should be, obviously it has to be. What am I going to do? Where is it going to go? Like obviously it has to be connected to an external circuit, but my point is a capacitor and a resistor, okay? Now here is the crazy thing about EIS that you don't get in DC based techniques, okay? Is that EIS, right, can also tell you the combination or the effect coming from the capacitive and the resistive part. Because when you go into the detail of understanding what an electrode is, this is your electrode. Let's say, Chian, what is your material? Carbon. Carbon electrode, right? You can think of it like a metal, right? And then you have whatever you have on top. Let's say you put gold nanoparticle and antibody. Okay? This is the solution, right? Yeah? So, the solution you can think of as one